All right, example 2 is our ACE novelty example from the previous section. Okay, so we had two types of souvenirs. We had some information about the profit we got from each type of souvenir and how much time those souvenirs take to manufacture on the couple different machines. And the machines were constrained by the amount of time that was available. All right, so we formulated this linear programming problem in the last section. All right, so what I've done here is just put the linear programming problem. So we're trying to maximize profit, which is basically 1x, which right, because there's a dollar per unit profit for type A, times $1.20 times the number of type B souvenirs, and then we had these constraint equations that because the amount of time we have available on the machines is limited. All right, so now we're going to try to solve this linear programming problem. All right, so I'm going to kind of scroll down here so we just see the linear programming problem and the graph. And the first step is to graph the feasible set. All right, and the feasible set is determined by these constraint equations. So we're just going to graph the constraint equations. So let me see here. I'm going to pick up the red pen. Let's graph the first equation in red. All right, so I'm just going to pick a couple of points and draw a line because I know this is a linear constraint. And so it's going to make a line, and I'm just going to find the x-intercept, or as well, let's find the y-intercept first. When x is 0, I get the y-intercept, so that's 180, right? When x is 0, this 2x term goes away. I just get y is equal to 180, and when y is 0, that will give me the x-intercept, right? So when y is 0, I get 2x equals 180, so x is 90. All right, so I can graph those 2 points. So my y-intercept is 180. And then I have 90. Okay, so that's probably about here. Okay, I'm just going to connect those 2 points with a line. All right, so let's see how well I can do here. Okay. All right, so there's my line. All right, so let's take a look at the next constraint equation. Again, I'm just going to find the x and y intercepts. That's the easiest thing to do probably if I can. And so when x is 0, I get the y-intercept. So 3y equals 300. So that just means y is 100. And when y is 0, then x is 300. All right, so I'm going to plot those 2 points. So I got a point, my y-intercept is 100, and my x-intercept is at 300. And then I'm just going to try to connect those points. Let's see how straight of a line I can make. Okay, good enough. It's not that critical. I mean, I'm not actually gonna try to read the values off graphically. But you can see now. I should also again, because these are inequalities, I need to know which side of the line I should shade, right? So I know that if I put 0 for x and 0 for y in for this to the second equation right here, then that gives me a true statement, right? So 0 is less than 300. So I know I need to shade that side of the line. And for the other line, again, if I put in 0, 0, that makes it a valid equation. And so it's going to be that side of the line. And then I also have the constraints that x and y are greater than 0. All right. So I want the set of all the x and y values that satisfy all of those equations. So it's going to be this region right here. All right, so that's my feasible set. That's my feasible region. That gives me all of the possible x and y values that satisfy those constraint equations. And then I just have to find the corners. So I already know some of the corners. Like this is the corner 0, 0, right? I know that this is the corner 0, 90, right? And I also know this point, I can just call this 0, 100. All right, so I just need to find this. I need to find that intersection to have all of my corners. All right, so the first step is just to find the intersection. Intersection. Okay, I need to find the intersection of these two lines. All right, the 2x plus y equals 180 and x plus 3y equals 100. Okay, so I'm going to just rearrange this equation. If I subtract y from both sides, or actually, I'm going to subtract 2x from both sides. I'm going to subtract 2x from both sides, and that way I get an equation in terms of y. So I get y is equal to 180 minus 2x. Okay, that's that first equation that I have graphed in red. And the other equation is 3x plus, or sorry, x plus 3y equals 100. And so I can substitute this value for y. So I get x plus 3y, and instead of y, I'm going to write 180 minus 2x. I'm just solving it by substitution, equals 300. All right, so now I just need to do some algebra. So let's first of all just multiply through the parentheses and distribute the 3. So we get 540 minus 6x equals, oops, that should be 300, right? 300. All right, now let's see. I know that x minus 6x is minus 5x. I'm actually going to add 5x to both sides. All right, and that gets rid of this, the x's on the left, and I'm going to subtract 300. All right, so I get 5x is equal to 240. And if I divide both sides by 5, I get x is equal to 48. All right, so that gives me the x value of that intersection. I need the y value, and I have the equation here that I solved for y. So I'm just going to take that equation. Y is equal to 180 minus 2x. X is 48, and then I get the corresponding y value, which is 84. All right, so my intersection is the point 48, comma 84. All right, that's this point right here, 48, comma 84. Okay, that's the hard part. Now we just need to evaluate the corners. So what I'm going to do is I'm just going to take my profit function and plug the values for these corners in. So I'm just going to start with 0, 0. So I put 0 into my profit function. I get I just get 0, right? So that's definitely not going to maximize my profit. All right, so and so then I'm going to move my way around this polygon here, this feasible set, and plug in these different values. So when x is 0 and y is 100, I get 0 plus 1.2 times 100, right? Because I'm making $1.20 on the type B souvenirs. So that gives me a profit of $120. All right, let's keep moving our way around. The next corner is the one I just found, 48, 84. If I plug that in, I get 48, right? 1 times 48, because I'm making $1 profit on each of the type A, and $1.20 profit on the type B, so 84. If I add that up, I get $148.80. Now I just realized that I marked at this point wrong, because this should be actually 90, 0, right? So my last point that I want to evaluate is 90, 0. So if I plug that into my profit function, I get 90 plus 120 times 0, which gives me a profit of 90. All right, so we just got to pick the biggest one. And it appears that this is the biggest one right here. So this is our maximum. All right, that's our maximum. So let's state the solution to this problem. We will, so we're going to say that ACE novelty will have a maximum profit, of $148.80. When, right? Because we wanted to know how many of each type they need to manufacture to maximize their profit. So so we need to state the number of each type. So when they produce, produce, come on, produce 48 type A souvenirs and 84 of the type B souvenirs. Type B souvenirs. All right, so that's my final answer. All right, they're going to make a maximum of $148 when they make 48 type A's and 84 type B's. All right, so you're probably getting the hang of it. I'll meet you in the next video for example 3.